Hi, this is Mr. Mack. This is the first concept video on the Session 6 notes, Statistical Test Inference. All right, now this first page is pretty straightforward. There's a couple of things I do want to mention here, and the first one comes right here. I want to talk for a moment or two about the difference between descriptive statistics and inferential statistics. This is a topic of discussion amongst IB examiners, and one of the things that they want the students to understand is the difference between statistics done on a population and statistics done to a sample to infer something to a larger population. Now, descriptive statistics are when you take a data set and you compute the standard deviation and the average and variance and other things like that, and you look at how that data set behaves itself. Now, inferential statistics are when you take a sample from a larger set and then you attempt to say what's true of that larger set. Usually we call that larger set the population, from the sample that you've taken. Now, obviously, if you're doing statistics on a population, in other words, you've got maybe a test that you've given to 100,000 people and you just crunch the numbers on all of them, then you know exactly what's going on with that population. But if you've got a larger population and you're trying to figure out the average or something like that, then your sample mean or standard deviation might be somewhat different. So in the last session, we talked about how we could create an interval around our sample statistic, our computed statistic, so that we would be 90% confident or 95% confident or even 99% confident that our actual population statistic is in that interval. Now, there's some vocabulary here to go over again. I'll let you read that. I do want to get down here to theoretical and experimental probability, and I'd like to talk to you about this one for a second. And one of the easiest ways to do this would be to talk about something very simple, like flipping a coin. Now, if I were to ask you, if we take a quarter and we flip the coin, what's the probability that we would get heads? Probably everybody would say 1/2. Well, the way you get the 1/2 is you say, all right, if we're going to flip the coin, then there are two different things that could happen. We could either get heads or tails. So on the bottom of the fraction, we put the number of different possibilities. And of those possibilities, only one is a head, so we put the number of successes on the top, and that would be the theoretical probability of flipping a coin and getting a head. Now, if I took a quarter and I flipped it 17 times, well, if I flipped it 17 times and then I counted the number of times I get heads, I wouldn't, if I took the number of times I get heads over the number of times I flip the coin, that would be an experimental probability. Now, a lot of you would say, well, yes, you might not get 1/2. Well, in that case, if there were 17 times, it definitely wouldn't, because you would have to get heads 8.5 times in 17 flips for the fraction to actually become 1/2. So, but as you flip the coin more and more times, you would expect that your experimental probability or your observed probability would get closer and closer to the theoretical probability. Now, on the next page, we have some talk here about a simulation, and we've got here a simulation that I wanted to spend a little time with, and it's a simulation about a basketball player who is an 80% free throw shooter. And the question is, how many shots can she make in a row without missing? Now, there's a way to do this theoretically, and I actually have done that, but before we actually get to that number, and I haven't even decided for sure whether I'm going to give you that number or not yet. Before we get to that, let's run a simulation. Now, I um, I've created a spreadsheet, and I'm going to put this up on the screen here and talk to you about this spreadsheet a little bit, and then we'll actually run through it. Now, this is the spreadsheet that I've created, and a couple of things. This percentage right here, as a decimal, is the percentage of shots that the basketball player makes. In other words, over a long period of time, it's expected that she is going to make 8 out of every 10 of the shots that she makes. Hi, I'm back. Now, this is the percentage or the proportion of shots that she takes that she makes. Okay, now what I've got over here is I just made this column. Column C is 1, 2, 3, and so on like that. And see, this is kind of general because I can copy this formula down. But the idea here is how many shots out of 10 will she make before she misses. Now, what this formula right here does is it just takes a random number between 0 and 1, and if the random number times A2, now this is A2 right here, is greater than A, let's see, if random number is less than A2, then she made the shot, and if it's greater than A2, she misses the shot. So anything, if the random number is 0.1, 0.2, 0.3, 0.15, something like that, it will interpret that as she made the shot. If it's 0.83 or something like that, it'll interpret her as if she missed the shot. And then the 1 is what happens if this is true. In other words, if it's less than it puts a 1 here, and if it's greater than it puts a 0. Now, every time you type something into the spreadsheet, I'm going to come over here and click on this one right here, and if I put a 2 and then enter, notice what it did was it recalculated all of these shots right here. Now, this counts how many shots she made, and this gives the percentage of the shots that she made of the first 10. Now, this number over here averages all the numbers inside this. Now, what this one is, this is your observations, and I'm just going to highlight all of these and clear them out, and we're going to get a division by 0 error right here because it doesn't, it's averaging all these up and there isn't anything to average, so it says it's dividing by 0. Now, what we're going to do is we're just going to look at what we're going to do is we're going to look at this column right here, because our question is not how many shots she makes out of 10, because we already have that 0.8 kind of, although it's going to be more or less in any particular simulation. But we want to know how many shots she makes until she misses one. So we're going to look at the highest number that's 1. Now, in this case here, for example, she missed the very first shot. Now, she made 7 shots, but she missed the first shot, so the number of shots she took till she missed was actually 0. And so I'm going to put a 0 right here and press enter. Now, notice what happened is it recalculated. Now, we look over here. She missed the 6th shot, so the answer is 5. And so I'm going to type a 5 and enter. And now, notice she missed the 4th shot, so I'm going to type a 3 and then enter. Now, you can do this if you look, except for, well, actually it'll average these 2 dark blue spots also if you do them. But the idea is, what is the idea? The idea is that if you put in number in each of these spots, this time it was what, 6, enter, then we will have done 50 trials of this basketball player taking 10 shots, and we'll have an average number of shots till a miss. Now, you would think that if she makes 80% of her shots, that it would be 8 shots till she misses, but that doesn't turn out to be the case. This is a different question than how many shots out of 10 will she make. This is how many shots will she take before she misses one. And that's a little bit different. Now I'm going to put this spreadsheet up on the course webpage, and so you can run your own simulation with this one as well. And so I think I've explained it well enough for you guys to give that a try. So enjoy that. Now let's see, was there anything more I wanted to do on this first video? No, I think I'm going to pause the video or stop this video here and start the second one. So here we go. We're done with the first one.